Hey everybody, here's some practice for finding a GCF. They call it a drag and drop, but that's just a fancy word for fill in the blank. So remember, our GCF is our greatest common factor. So what we're looking for is the biggest number that we can divide out of all three of these values in the polynomial. So remember, each polynomial is a collection of terms. This polynomial has 1, 2, 3 terms. This has 1, 2, 3. In fact, as I look down the worksheet, they're all going to be trinomials. So remember, a trinomial is a polynomial with 3 terms. So none of these can be possibly less than a quadratic because it has 3 different terms and they all are simplified and in standard form. So when you look at these, we've got all kinds of x's and y's, and we want to take this bit by bit. So the first thing I'm going to do is take a look at each of my coefficients. So when I am going to include the signs in each of these, if my coefficient is a positive, my leading coefficient, I'm not going to be dividing out any negatives. But if my coefficient is negative, then I want to make sure I include the dividing of that out. Okay, so I hope you have Desmos handy, because what I'm going to do is I'm going to bring in, we've got a 24 and a 9 and a 12. So we'll go ahead and bring Desmos into the conversation. And think about, do you remember what 3 letters we type in? Greatest common factor. And we're going to use a parenthesis, and then we want to make sure that we remember what coefficients that we are considering. So if I pull my worksheet back out, I know we were looking at 24, comma, 9, comma, and 12. So I can see that each of those values can be divided by a 3. So we'll go ahead and we'll know that this 3 is what we can divide out of each. And when we do that, we can think about it as dividing the 3, knowing that 24 divided by 3 is 8. Negative 9 divided by 3 is negative 3. Negative 12 divided by 3 is negative 4. So that's our coefficients. Now we're going to take a look at each of the variables. So the variables here, we have 4 x's. Here I have 3 x's, and here I have 3 x's. So the question is, what is the greatest number of x's I can take out? And that's going to be these x's right here. So if I can take out 3 x's, what does that leave me with? So when I take out 3 x's here, I end up with 1 x left. When I take out 3 x's here, that leaves me with no x's. When I take out with 3 x's here, they completely cancel out, so I don't need to list my x's there at all. All right, so let's take a look at these y's. I've got 1 y here, and 3 y's here, and 2 y's here. So the greatest common number of y's is going to be this 1 y here. So my 1 y can come out, and when I divide out those y's, they cancel out, so no y's are going to be there. When I take out my 1 y from this 3, I'm going to be left with 2 y's. And when I take out my 1 y from these 2, that's going to leave me with 1 y. So if you look at, there's no common numbers. I didn't miss any. This guy has 1x, none for these. This guy has no y's, and he has 2 and he has 1. So I know I found the biggest combination of factors that can come out. Now, the way that we did things here might seem a little long for you. So maybe what you might want to do is, if you're comfortable with what you're doing, you can kind of elevate your knowledge and say, okay, when I look at each of these numbers, I know a 2 comes out. So there it is. When I look at my variables, I know I have 2 x's, 1 x, no x's. So no x's are coming out. And I know I have 1 y, 2 y's, 1 y. So each of these y's is going to come out. When I know that I'm dividing a 2y from each thing, here it is. I'm pulling it out of that expression. So when I look at what's left, 2 into 24 goes 12 times. I didn't take any x's out, so those 2 are still there, and my y's cancel out. Plus 9, no x's were canceled out, and 1 y was taken out. Now careful here, because you seem to think, oh, 2 and 2 cancel out, and 1 and 1 cancel out, but guess what? I still need that placeholder. When you divide them, you get an answer of 1. All right, let's take a look at our next one. If I have 24, 18, and 12, and I want to find my greatest common factor, in case those numbers are not familiar to me, I can go back and again use my GCF function. So I'll go to Desmos and I'll type in the greatest common factor, and I'll put my parentheses. And my numbers again were 24, 18, and 12. And I can see here the greatest common factor, the number that comes out of each of them, is going to be 6. So, okay, we'll go ahead and say that a 6 comes out. Divide each by 6. And that's going to give me 4 here, and a negative 3 here, and a positive 2 here. Let's talk about our variables. I have 3 x's, 1 x, no x's. Guess what? None of those x's can come out. So everybody sticks with their x. All right, let's talk about y's. We've got 2 y's, 3 y's, and 3 y's. So it looks like that's my smallest number. 2 y's are going to come out of each one. And whatever I'm dividing everything by, that's that factor that I'm pulling out, the greatest common factor. The largest coefficient and the largest variable that comes out of each. Okay, so let's talk about what we have left. These 2 y's cancel out. I don't need to write anything. These 2 y's cancel out with 2 of those, leaving me with 1 y. And these 2 y's cancel out with 2 of those, leaving me again with 1 y. Now, if you don't like the way that your value looks when you finish writing, you can go ahead and neaten it up a little bit. I left a little bit too much space here and didn't give him enough room. So if you want to neaten it up, you absolutely can. So what this is, it's unsimplified. I've factored. I've introduced parentheses, and I've let it known that this is not simplified. If I wanted to, I could put this back in using the distributed property, and I'd get my original polynomial. But that's not what we're doing here. When we're factoring, it means we're taking something out. We're unsimplifying. And you'll see why we need to be able to do this in a little bit. All right, we'll move on with these. Go ahead and pause the video, and you work on this and come back to check your answer. All right, so check it out. No variables were able to be divided out. So each of these values could be divided by 3, leaving me with an 8 and a 3 and a 4 as coefficients. My sign stayed the same with my minus here and my minus here. When I went to divide out my variables, this guy has no y's, this guy has no x's. So there's no common variables in this one. So that's okay. I took a 3 out, and that'll be good enough. All right, let's take a look at number 5. Pause the video and see how you do. All right, so let's talk about this one. 24, 16, and 12 all have 4 as a common factor, so I divided that out of each of them. Every single one of these terms has an x, so I divided 1x because this is my greatest common factor. I only have 1x here, so I can't take out any more than that. That leaves me with 2 x's and 1x in these two terms, none here. And then when I took out my y's, this is my smallest value of y. So I went ahead and took him out. That's why there's no y's here. 1 left and 3 left. All right, I hope you're getting the hang of this. Go ahead and take a look at 6 and tell me if you can tell right away. Try not to use Desmos because I think we've used this one before with 24, 18, and 12. Go ahead and take a look at number 3 and see if you can find the greatest common factor. All right, so I was able to take a 6x out, and I was able to have 4x squared with my 1y. This guy didn't have a y, so it wasn't common. If a variable is common, that means that every term has it. This guy has no y's, so I couldn't divide out a y from each term. All right, check out number 7. So this one was a little tricky. The 2 is easy to find, but you had to remember that when you divide 2 out of 2, that leaves 1. And if you want to think about that invisible 1 here as a coefficient, you can. Typically in mathematics, we don't include that 1 as a coefficient, just the same as we don't include 1 as a power on x when we take that out. Okay, we were able to take the x's out. They completely canceled out here, leaving me 1 here. And then I found my smallest number of y's was y squared. I have y times y. And then I have 2 left over and 1 left over when I divide out those 2 y's, those 2 factors of y. All right, here's our last one. See if you can get it perfect. Ready? Pause the video. Okay, check it out. So here we have 4x squared y. And it's interesting, when we take it out of this last fraction, we remove all of our variables, leaving us with a constant. So 3 is what we call a constant term, meaning that there are no variables left. Here is a 6 and there's a y, so neither of them have any common factors, so I know I found the greatest common factor. Remember, for a rule, you want to try to find all of the factors that come out, both with constants and variables, so you're looking for the greatest one that you can find. All right, now I'm going to play a few games with you. Let's go ahead and turn the page over and see what's there. Okay, so here's a little game that we can play, and what we're looking at here is factor tables, and you've seen us use these when we go to simplify radicals. You've seen me say, okay, let's think about 16 and all the factors that multiply together to give you 16. And we talk about 1 and 16, 2 and a number, and 4. When we talk about 20, we talk about, okay, I know that if I talk about the factors of 20, 1 and 20, and a number and 10, and 4 and a number. When I talk about 28, I can see 1 and 28, 2 and 14, but 4 and, what's that number there? When we talk about 36, here we have some number and 36, 2 and 18, some number and 12, 4 and some number, and then some number and 6. Okay, so we're going to pause the video. And the rule is for the game is you have to choose each one of these tiles 1 through 9, and you can only use each one time. So go ahead on your paper and tell me where each of those factors fits in the boxes. Go. How did you do? Did you get them all right? So anytime I talk about a factor table in future videos, I really want you to pay attention to what we're talking about is understanding all the possible combinations of factors. So when we start labeling things, I know, for example, 36 is a product. A product is the answer to a multiplication problem. When we're talking about the factors, I want to know what two things times each other can give me 36. And in future lessons, we're going to be talking about trying to find each of these factors. So like I said, knowing your multiplication facts becomes super important in being able to break down each of these values. Okay, here's one last final game for you. This is called X's and Ooh Yeahs. So what I want you to do is I want you to study these 3 puzzles. Those number puzzles have been completed. And I want you to try to see if you can find a relationship between those numbers. So remember, in mathematics, all we have is addition, subtraction, multiplication, and division. We can obviously talk about squaring things. We can talk about finding the square roots of things. But we know that these are actually just fancy forms of multiplication and division. So what I want you to do is take a look at each of these 4 and see if, or each of these 3 puzzles, and see if you can figure out the game. I'll pause the video and give you a minute. How did you do? Did you get it? So here's the pattern that we were hoping that you would see. This number here represents the sum of 2 numbers added together. So if I say the sum of 2 numbers added together, can you guess which other numbers in the puzzle? So yep, 4 and 9 add to 13. 1 and 12 add to 13. 8 and -3 add to 5. All right, so let's be a thinker. If this was the sum of these 2 numbers, what do you think is going on with this one? Okay, this one is the product. So when we talk about the product, we're going to go ahead and say that 9 times 4 is 36. 1 times 12 is 12. And 8 times -3 is -24. Now, again, you need to be able to do this math in your head. So if you are one of my friends that struggles with this, make sure you go play some games of Math Fact War, because you want to make sure that you know what it is that you need to do. All right, let's talk about the pattern that we saw. So, so the number on the left, number on the left is the sum of top and bottom numbers. And then, of course, we have the number on the right is the product of the top times the bottom numbers. Okay. So now that we have that number puzzle memorized, why don't you go ahead and see if you can fill in these numbers and find 2 numbers that add to this number and multiply to this number. Give it a minute. So pause the video and see if you can fill in and solve each of these number puzzles. 2 numbers that add to this and multiply to that. Pause the video and see if you can do it. All right, are you ready? it's easier for me to start with the product. So when I look at 16, I'm going to go ahead and look at the top of the page. Do you see these factor tables? Which two sets of numbers add together to give me what I want for my sum? Yep, you got it. 8 and 2. And guess what? It doesn't matter what order you put them into the puzzle. So if you said 2 and 8, that's also correct. Because with the commutative property, it doesn't matter. 1 and 16, no. 2 and 8, yep, that works. Okay, we'll look over at 36. Two numbers that multiply together to give me 36 and add together to be 12. All right, let's see 36. I can do my factor table, or I can look back here. I'm looking for a sum of 12. Aha, there it is. So I can see that 6 and 6 multiply together to be 36 and add together to be 12. 6 and 6 is my correct answer. Okay, so this one's a little tricky because do you see that negative sign? We're going to have to try to find two numbers that multiply together to be negative 24, which means one of these values is going to be negative. So let's ignore that for now and just list our factors of 24. 1 and 24, and 2 and 12, 3 and 8, 4 and 6. I think we got them all. So hey, if you need some help with that, here's a quick shortcut for the calculator that'll help you. So are you ready for this? If you take the number that you're looking for and you divide it by all the numbers in the whole wide world, that's x. When you go to the table of values, you're going to get all of the numbers that you're looking for. Now, of course, dividing by 0 gives you an error. You're not surprised to see that. But 1 and 24, 2 and 12, 3 and 8, 4 and 6. If you get a decimal, don't include that. It doesn't go in evenly. Once it starts to repeat, you don't have to worry about any more factors. So here we have 1 and 24, 2 and 12, 3 and 8, 4 and 6. What is that you said? You don't have a calculator? Guess what? Desmos can do this too. Are you ready? 24 divided by x, all the numbers in the whole wide world. So if you want to see that table of values, if you come back and you hit this setting, and then you get to click on this convert to table, now you can see -2, -1, 0, 1, and 2 as inputs. But guess what? You can go ahead and hit 3, 4, 5, 6, 7, and you can see all those same values that we were able to see on the calculator. So Desmos continues to be a great resource for you. All right, back to our example. We have a negative product, so we know one of these things has to be negative. We have a negative sum. So when I look at that, the only way I get a negative sum is if my value with more negatives was negative. So -8 plus +3 is -5. So I know it has to be -8 and 3. All right, now that we've done the first 3, you do the next 3 by yourself. All right, check them out. How'd you do? +3 and -3 gives me a sum of 0 and a product of -9. -6. Oh, this is supposed to be +6. No, that's right. -6 and -1 give me a sum of -7 and a product of +6. 21 and 1 give me a product of 21 and a sum of 22. Okay, guess what? You know that I want you to get lots of practice. So there's games, for you to practice solving number puzzles, because trust me, you're going to want to know how to do this. All right, hey, now that you've done this practice worksheet, go ahead and click on the Google form, and let's go ahead and give you some points for all your hard work.